Recorded is relevant. It's Wednesday, February 18th. Gonna do lesson 9.4 with you guys, which is more graphing. Yesterday, we were looking specifically at reciprocal functions. This is actually not that different. It's rational functions. Okay, but there's some fun examples in here. We'll be looking for asymptotes like vertical and horizontal asymptotes. But there's a new concept that shows up. It's called oblique asymptotes. You get an asymptote that's like a diagonal. Right? So we're gonna do couple of those. Okay. All right. And then you guys know, of course, this new Algebra Science has been open for a few days now, 9394. That's a single assignment. Right. So, oh, and also don't forget this too. Your 70% Pi goal is coming up in a few weeks, coming up pretty soon. Okay, so since we've been here for a while, I'll do some class notes with you guys, give you guys points for those, and then give you guys about the second half of class to be working on these Algebra assignments. All right, so put your name on your paper. All right, so everybody's got their name on the paper. Name on your paper. That's what you name. All right, and these are 9-4 notes. Okay, so I'll do some key fundamental examples with you guys. Yeah, thank you. All right, you got some paper. All right, so class notes. Class notes. 9-4. Okay, so graphing rational functions. Okay. All right, so just like always, I recorded a video that's about an hour long. I go through all these book examples and all these green highlights and things like that. Okay. But we'll pick out some with you guys here. We'll do together. That's a little bit different from those. All right, so if you need extra examples. And so number 2, let's start with the word puzzle. The constant set to create a certain part of a small engine is modeled by this expression right here, where x is the number of parts made. Okay, so we've got a factory example. Okay, it says graph the function, find and interpret key features of the graph. Oh, okay, so this is my thing. So I've got number three, factory. So here's the function, f of x is equal to 18x minus 12, all divided by 6x. Something like that. Interesting. Now, do you guys see that the degree of x on the top and degree x on the bottom is each one? You guys see that? Okay. Now let's think about what that means long term. Like if we pump out like 1,000,000 factory parts, guys, if you plug in like 1,000,000 for x, does this minus 12 right here become sort of negligible to the overall process? Right? Because we've got 18 million here and 6 million here, and minus a tiny, tiny bit that's mattering less and less the more parts we produce proportionally. Okay. So guys, what I'm trying to get at is the idea of a horizontal asymptote. Who can tell me, based on what I've said so far, what is the horizontal asymptote going to be? At y equals, guys, if again, let's pump out 1,000,000 parts. What's 18 million divided by 6 million, basically? 3 million. No, the millions cancel. Yeah. Right. Well, I can do this. Okay, here, you can sit closer if you have to. Okay. 3. Yeah, y is equal to 3. Okay. Okay, so this whole thing is going to asymptotically approach 3. Okay. All right. So that would be like 3 cents per part. Okay, 3 cents per part, basically. Okay. How about vertical asymptote? Asymptote. Okay. Now that would be at x equals something. Okay. Now, guys, how were we finding vertical asymptotes yesterday? The rule is you're not allowed to divide by what? 0? Can't divide by 0? Okay. In this case, well, there's just a 6x term at the bottom, so x would go to what for? How about 0, right? Right. Okay. If it was like plus 5, I'd have to do a little calculation, but just divide by 6x, yeah. If x is 0, you'd be dividing by 0, not allowed to do that. All right, so let's get some axes going. Okay, x-axis, y-axis. So here's x, here's y. Okay. There's a question, what's the cost of the 6th part? So I'll make a little xy table over here. Okay. And since this is a factory in parts, let's just go positive values of x. Let's go the cost of the first part. Let's go to the 6th part, the 10th part, and how about the 100th part? We'll do that. Right, so calculator, I'll do in parentheses. Here, guys, try this calculator trick with me. It's good practice. Do 18 times answer. Can everybody do that? Open parenthesis, 18, answer. Can they not do that? You may not do that. So everybody knows how to do that? Now do minus 12, then close parenthesis, then divide by, and then also put this in parentheses. 6, answer. Okay. Answer is the second negative key here. Okay.
I don't have that on this one.
Well, okay, yeah, you have to have this model calculator. Okay, so get one of those here. I see a bunch of them all around. It has to be this model. Okay, now plug in the number 1, enter. Okay, now the calculator's thinking, okay, something about 1. Scroll up and plug that in, and you get 1. Right, so if you plug in 1, you get the number 1. Okay. Plug in 6, scroll up, plug it in, I get 2.67. Right. Yeah, one of the questions the book was asking was how much does it cost for the 6th part? So it looks like about 2.67 cents. These are in cents. Okay. How about
96?
Huh?
About 92.
You got 96. Then you plugged it in wrong. Right. So here, guys. Here. I'm gonna clear this out. I'll type it again. So to open parenthesis, 18 answer minus 12 close parenthesis. Okay. So now all that's grouped. Okay. Then hit divide by, and then it's really important you hit an open parenthesis here because there's 2 things multiplied. They're both in the denominator. So do 6 answer. Okay. Okay. All right. So then if I type 6, I get 2.67. Okay. How about 10 for the 10th part? Costs $2. Sorry, these are cents. 2.8 cents.
Yeah, 2.9.
Well,
was there anything after the 6?
6. X, which is answer. Here.
Yeah, I did that.
So if I scroll up here, I'm going to divide by, and then parentheses 6 times the answer. Right. Answer being whatever the previous entry was. So if I type 10, plug that in. 10. There we go. You get 2.8. If I type 100, plug that in, I get 2.98. Okay. Well, let's plug those points in. So here it could be 1, 10 might be there, 100 might be here. I don't think that's exactly the scale, but it should be pretty close. Okay. And then what are these costs and cents? They got 0, 1, 2, 3. Okay. So the first part costs 1 cent to make. Boink. The 6th part with 267. That's like right about here. The 10th part 280. 100th part 298. Right. You guys see the pattern emerging here? Is it gonna look basically like this? Is it? Right. And look at maybe actually I should have drawn the asymptotes first to frame this because I told you from the outset. That's one of the first things we walk through is that there's going to be a horizontal asymptote here at y is equal to 3. Yeah, so this will asymptotically approach y is equal to 3. Okay. And there's a vertical asymptote x equals 0. Yeah, that looks consistent with the graph too. Does that look about right? Isn't it? Okay. And then also I put this into Desmos. I put all the ones into Desmos that I want to do ahead of time. Right. So here, that's the equation we're working with. And yeah, and there's the curve. Right. Now we're not making a negative number of parts. Right. So okay. But really this part of the graph right here. Isn't that what we just made? Looks like that. Yeah. All right, so we're good so far. One down. Okay, got our classic horizontal asymptote, vertical asymptote. Plug in some points. All right, everything's good. All right. Now, guys, these next 2, or that I want to do with you guys, both involve what's called an oblique asymptote, or when I learned it back in high school, called it a slant asymptote. Okay. This is new. We haven't done this yet, and I'm going to do 2 of these with you guys. This is going to be new. Okay. So number 10. I'll point out the equation. What to look forward to. So number 10. I got f of x equals, okay, so some fraction going on. I got 2x squared plus 7x in the numerator, and I got an x minus 2 in the denominator. Okay, what's that? Now, for the, okay, let's guys copy that. You see that? Okay, now if I go back to the previous question, how did I get the horizontal asymptote? Remember I plugged in like 1,000,000 for x, like we're pumping out 1,000,000 parts of the factory? Okay. It's like, okay, well, it's asymptotically approaching 3. And the graph also backs that up. It's asymptotically approaching value y equals 3. Okay. Now, if I take this same thought process to this one, now this one doesn't actually have a horizontal asymptote, right? Because the degree of x on top and bottom is not the same. You guys see a degree of 2 on the top and a degree of 1 on the bottom? Right? Okay. But guys, if you plug in a big number like a million for x, do you think this 7x and this 2 over here would become negligible to like these other terms would dominate, wouldn't it? Right. So 2 times a million squared over a million. Okay. Well, one of the millions cancels. Okay. Could that because 2x squared divided by x. Again, I'm ignoring the part that I'm covering up here because I'm saying what's it going to sort of asymptotically approach. Okay. Does that simplify very simply to 2x?
Yeah.
Is it? Okay. So if I said y equals 2x, y equals 2x, hey, is that a diagonal line with a slope of 2? Right. I think that's something like what this asymptote is going to be. Now, the proper way to find it is to use long division. Okay. Actually, right before I do it, I should do vertical asymptote first because we can knock that out real fast. Okay. Guess what's the vertical asymptote equal to? Yeah. Okay. At x equals positive g because you're not allowed to divide by 0. Okay, so we've done that in the past. You guys know that one. Okay. Now the oblique asymptote. Here's what's new. The oblique asymptote, or slant asymptote. Slant. Okay. We're going to use long division. So I'll spell out long division. Okay. So let's take 2x squared plus 7x and divide by x minus 2. Okay. So if we'll run a long division process, whatever comes out of this, again, represents what this whole graph is going to asymptotically approach, but it's going to be like a slant asymptote. Okay. So how many times does x go into 2x squared? 2x times. Then 2x times x is, of course, 2x squared. We set that up to happen. But 2x times negative 2, guys, is that like negative 4x? Is that true? 2x, I'm just doing long division. Okay. Subtract this off. This, of course, goes to 0. We set that up to happen. All right. Now, negative, negative. Does that turn into a plus if I distribute the negative? And this creates what right here? 11x. Okay. Does x go into 11x? How many times? 11 times. So let's do plus 11. Actually, that'll also be part of the slant asymptote too. Okay. Let's do 11x is 11x. And then minus 22. Subtract. I get positive 22 here. Okay. So this whole thing plus, and then here's your remainder. 22 over x minus 2. That bit right there. Okay. So this right here.
Would it be negative?
Well, I'm subtracting a negative.
Oh,
Yeah.
it's negative.
Okay. Yeah. So get that. Okay. So you guys see that everything? Okay. So it again, the idea is if you let x become extraordinarily large, like you put in a million for x, that I mean, it comes out to this whole thing that I circled, but this last bit right here, this remainder looking bit, is going to approach 0 itself because it's like 22 over a million. That's just going to kind of go away eventually, become negligible. Okay, and you're left with this 2x plus 11, and that's what this graph is asymptotically approaching. Oh yeah.
Which, no, 11x. It's sometimes minus 4, so it will be 3x.
Well, it's minus a negative. So guys, you have to distribute plus, minus, plus, and then same thing here, plus, minus, plus. Yeah, so like that. Okay. All right. Okay, so you guys got that? Okay. All right. Okay, let's make this graph, but really I'll start with the asymptotes. I probably should have done that with the last one. Anyway, start with the asymptotes. Okay, let's do that. Okay, so this is still number 10, continued. Okay, let's get a big old graph going. Here. Should over here. Big old graph.
Yes.
Okay. Okay, so you got x-axis, y-axis, and okay, so let's go. It's kind of weird. Let's go 10, 20, 30, like this. Okay, and then let's go 10, 20, 30, 40. So, yeah, 10, 20, 30, 40. Okay, is that okay so far? It's got basically that. Okay. Now, I know that there's a vertical asymptote, of course, at x equals 2. So let's draw that in. That's probably right about here-ish, probably pretty close. Okay, vertical asymptote. Not allowed to divide by 0. Hence that vertical asymptote. So we got that. Okay, so everybody dashed off the vertical asymptote at x equals 2. Okay. Now the slant asymptote, this oblique asymptote. Okay. That's going to be basically y equals 2x plus 11. Right there. Y equals 2x plus 11. Okay. So plus 11 is right here. And rise over 1 of 2. Can you guys go up? Let's see. Up 2 over 1 would be right about here. Okay. That's pretty close to this. Gonna dash off. Yeah.
What would the y-intercept be? Because when x equals 0, would be it would also be 0, right? Because it'd be 11 plus 0.2 over -2, which would be 0.
Okay, you're saying if you plug in
If you
0
plug
to
in
the
0
original
for
equation,
y-intercept.
to the original equation,
No, to the oblique.
to the oblique asymptote. If I plug in 0 here,
Yeah.
right. Well,
0 plus 11 minus 11, right?
0 plus okay. Yeah, that doesn't matter because the idea of an oblique asymptote is if you let x go to like infinity or negative infinity, it's what's going to asymptotically approach. So anything sort of around the origin, the the oblique asymptote is going to be less obvious, right? But if x gets really big, I would expect this function to sort of attract close to this asymptote, kind of like a magnet, but never quite touch it. Right? That's really what we're interested in. Right? But letting x go to like 1,000,000. If you let x go to 1,000,000, then now it's going to follow just 2x plus 11, and this last bit is going to be less relevant. Okay, so let's get some values here. XY table, XY. Okay, so let's go. How about -10, -5? Let's plug in 0, see what happens. Let's go 5, 10, and 15. I think that would be a good set. Okay. So then go back to the original equation here. So in parentheses, do 2 answer squared. Everybody got 2 answer squared plus 7. Whoops. 2 answer squared plus 7 answer. Then close parenthesis. So now all that's grouped together in parentheses. Then divide by, open parenthesis, answer -2, close parenthesis. Great. You guys got that in there? Yeah, answer is taking place of x. Now if I type -10 and scroll up and plug that in, it's telling me -10.8 something.
Wait, so it's 2 answer squared plus 7 answer and then plus 1?
No, okay. So see this right here, the original equation?
Yeah.
Everywhere there's an x, I'm gonna just put answer, and then I'll let the calculator fill that in. So I'm gonna do 2 answer squared, that's like 2x squared, plus 7 answer. Okay. Now that's very importantly all grouped together in parentheses. So now the calculator knows this is all grouped together in the numerator. Then divide by, then very importantly open up another parenthesis so you can start to group the denominator. Do answer -2. Okay. Now if I take -5, I can plug that in. I'm getting -2.14 something. If I plug in 0, I do get 0, because the numerator would be 0 over -2, still 0. 5, I get 28.3 something. 10, I'm getting 33.75. 15, I'm getting 42.69. Okay. So let's plot those points and see if the shape emerges. Okay, guys good so far?
Yeah.
So -10, -10.83. That's probably right about here. -5, -2 point something. It's probably right about here. 0, 0 is a point. 5, 28. Woo! 28 way up here. 10, 33 something is probably right about here. And 1542, that's like right here. Okay. Anyway, so those points. Okay. Now I could get more and more coordinates if I wanted to, okay, but I see what's going to happen. Can you guys predict? Here, if you guys got everything I got, I bet you can probably predict what the rest of the graph looks like. Okay. And if you weren't sure, you could always say, what if x is equal to 1.5 and get that coordinate. Okay. but I bet it's going to look like this. Where as you approach x equals 2 from the other side, you'll be approaching this vertical asymptote, so it'd have to take off like that. Okay. And if x goes to negative infinity or positive infinity, it should asymptotically approach this oblique asymptote. All right. Now, this one I also plugged into Desmos ahead of time. Oh, yeah. That is what we just came up with right there. Same thing. There's the equation, there's the graph. It's all the same. All the same. Yeah. And if I zoom out, yeah, that oblique asymptote becomes more and more obvious, doesn't it? Yeah. Okay, so you guys good? Okay. Now, since that's probably the first time you guys have seen an oblique asymptote, we're going to do one more that's basically the same idea. It has oblique asymptote over there. Okay, you guys ready for the next one? Okay. Let's do number 11, the very next question, number 11. There's a whole section up here that these are all going to be oblique asymptote or have oblique asymptote. And the reason I know, well, at least what would indicate that's probably the case, is that all these have a degree of x on top that's one more than the degree of x on the bottom. So when you do long division, you get a linear quotient. Okay? So like this one says 3x squared plus 8 all divided by 2x minus 1. But we say this f of x equals all that. Okay, be like that. Okay. Yeah, just like the previous one we just did, the degree of x on top is one more than the degree of x on the bottom, x squared versus x. So again, if you let x run to like a million, what's going to dominate is the 3x squared versus the 2x. Okay. That'll reduce to 3x over 2. Okay. But maybe there's also a y-intercept. So we have to do long division. Okay. Before I do that, let's get vertical asymptote first, because that's the easy one to get. Vertical asymptote. Yeah, I would say 2x minus 1 is not allowed to be 0. Therefore, x is not allowed to be exactly 1/2. Or you could say it's at x equals 1/2 would be the vertical asymptote. Okay, so that'll be helpful later. Now let's do oblique. Oblique asymptote. Okay, so what's that going to be? Long division. Let's do 3x squared plus 8. Then that's all divided by 2x minus 1. Okay. And just go through our long division rules. So 2x goes into 3x squared. I think 3 over 2x times 3 over 2x. 3 over 2x times 2x is, of course, 3x squared. We set that up to happen. And then this would be minus 3 halves x. Right? And then you can, of course, drop down the...
This 3x over 2 also one.
Yeah, same thing. Okay, so then I'm going to subtract this off. Here, I'll go ahead and distribute the negative. So plus, minus, or sorry, whoops, why did I do that? A is just going to drop down regardless. Get rid of that. Okay, so then this is going to be, of course, 0 here. We've got a positive 3 halves x. Okay, yeah, and we will drop down to plus 8. Okay, now, how many times does 2 go into 3 halves x? I think that'll be 3/4 times 3/4. We do 3/4 times 2. Yeah, it's 3/2. Okay. So it's 3 halves x. And then minus 3/4. Subtract. This goes to 0. Remember, you can distribute the negative. That helps. This would be plus 8.75 right here. Okay. So this would be plus 8.75 over 2x minus 1. Okay. So if you divide this out with long division, you get this full looking expression right here. Okay. This final remainder looking bit that has the fraction, that's going to become negligible as x gets very, very large. Like if you plug in 1,000,000 for x, this approaches 0. Okay. Never quite reaches 0, but approaches 0. Okay. So this first two terms that looks like a linear equation, that would be the oblique asymptote. So here, spell this out. Oblique asymptote at y equals 3 halves x plus 3 over 4. So now we have the vertical asymptote and also the oblique asymptote. Okay, you guys follow that? Okay, so okay. While you guys are digesting that, do a quick recap. I see it going back to the very beginning. Okay. I see this rational form, this fraction form of a expression. I see the degree of x on top is one more than that on bottom. That tells me there's probably going to be an oblique asymptote. So if I do long division, then I come up with this linear equation, plus this remainder bit. Right? And the linear equation part would represent the oblique asymptote. So of course asymptotically approach when x gets very, very large. Okay. Good so far. Good so far. Okay. All right, so same as before, got 11, continued. Okay. Let's get some axes going. X-axis, y-axis. Guys, let's go 10, 20, 10 here, 20 here, maybe 10 here, 10, 20, maybe 10. Okay. I think that'll be pretty good first right there. Okay. Now, I know that there's a vertical asymptote at x is 1/2. So it's probably right about here, right about here. So I'll dash off this vertical asymptote. Okay, that. So there's your vertical asymptote. Okay. Okay, and then there's this oblique asymptote. So y equals 3/2 x plus 3/4. Now 3/4 is probably pretty close to there. Okay. And then we have a slope of up 3/2. Can you guys do a slope of up 3/2? 1, 2, 3, 1, 2. It's probably pretty close to here. It's kind of eyeballing it. It should be fairly close to that. All right. There's that oblique asymptote. Oh god, spell out the equation. Y equals 3/2x plus 3/4. Okay, that's that oblique asymptote. Okay. Okay, so that'll frame the graph for us. All right, okay. That's good. That's good. Okay. Let's get XY table. XY, plots and points. Okay. So how about -10, -5, 0, 5, 10, 15. All right, see where that gets us. Okay, so in your calculator, let's do open parenthesis, 3 answer squared plus 8 close parenthesis divided by open parenthesis, 2 answer minus 1 close parenthesis. All right, then I can plug in -10. This tells me -14.67, -5, -7.55, 0, -8, 5, 9.22, 10, 16.21, 15, 23.55. Okay. Get those coordinates here. So -10, -14. It's probably about here-ish. -5, -7.5 is probably right about here. 0, -8. About here. 5, 9 point something is probably right here. 10, 16, probably right here. 15, 23. Okay. Okay. So I think it's going to look fairly similar to the previous graph. It should look something like this. Okay. All right, guys, go with that. Okay. And then what does Desmos say about that? So there's the equation, same equation, and yeah, that's the graph. That's the graph right there we just made. Same thing. Same thing. Oh yeah. Okay. All right. Gonna do one more with the guys. You guys ready for the last one? Last one. Okay. So let's do number 15 down here. Okay. And this is gonna actually also be a unique situation that I don't think you guys have seen before, maybe, but we're gonna find out. Okay, number 15. So I got f of x is equal to We got x squared minus 2x minus 8, all collectively divided by x minus 4. Right, is that okay? Now, we could say, okay, well, remember, you're not allowed to divide by what?
You know,
0. Can't divide by 0. In which case, x is specifically not allowed to equal what?
1, 4.
4. Right. Now, I would normally say, oh, well, there should be a vertical asymptote at x equals 4. But this is actually going to be an exception, and I'll show you guys why. Okay. Do you guys think you could possibly factor that numerator? Okay, let's do that. Okay, so the denominator I'll leave as x minus 4. But the numerator factors into what times what? Can you guys do that?
Oh, two.
Is it just the long division?
Yeah, x plus 2. Okay, you could use long division. That's true. Okay. Because if you have trouble factoring something, sometimes they say, oh, you could use quadratic, could help you figure out how to factor. You could also do long division. That's totally true. Okay. I'm doing like the reverse FOIL type method. It's be like this. So show you guys with FOIL. So first, x is x squared. Bing. Outside, negative 4x inside 2x. That makes negative 2x. Bing. And last, 2 times negative 4 is negative 8. Bing. So that does factor like that. Okay. Yeah. Long division will also get you there. Now, what do you guys see?
We cancel out the.
You can't. You can cancel out the x minus 4. And that leaves you with x plus 2. So this equation actually is x plus 2. It's the same thing with one caveat. And that caveat is x is not allowed to equal what?
Yeah.
Well, you can't divide by 0.
4.
Yes, so 4 in that case, right? Okay. So let's just graph that. Right? And that looks a lot more like Algebra 1 type graph, doesn't it? Okay.
No.
X, Y, go.
If it's
By-
40 done, you know, instead of 4.
Yeah. Okay. Right, so let's graph this first. Okay, so plus 2 is like right here. I got a slope of, slope of 1. Right, so what we got right there. So up 1 over 1, and so on. It's going to go like this. Okay. So it's going to create, here's your graph. Okay. But remember, x is not allowed to be 4. Now, if you did plug in 4, guys, what would the coordinate be? 4 comma what?
Undefined.
Oh, okay, yeah, undefined, but 6 is where it would be, right? So 4, 6. Okay. So guys, go ahead and do this. Put a little hole at the point 4 comma 6. 4 comma 6. Okay. That's called a discontinuity. Okay. Yeah, also called a hole. Okay. Like that. Right. Right, you guys good there? Right. And then I'll back this up also with Desmos. So find the tab. Did I pick a different one? I did. Okay, well here, I'll show you guys this one, then I'll show you guys the one we just did. So oops. Okay. Guys, this is different. But do you guys see that the one I typed here, this is going to factor x plus 5, x minus 5, and I'll cancel out with this x plus 5. So it should be a discontinuity at negative 5. And if I click on this graph, okay, it looks like a straight line. Looks like just looks like the line y equals x minus 5. But if I go down here, you guys see it says negative 5 comma undefined. It actually opened up a hole. If you click on the graph, it'll do that. But that's not the one we did. So here I gotta do the graph that we actually did here. All right, so Desmos. All right, graph calculator. All right, so let's do f of x equals. I'll do x squared minus 2x minus 8. Put that in parentheses. Divide by. And then in new parentheses, x minus 4. Okay. Okay. Now, remember, we know what this should look like because we just did it. It should be a straight line with a discontinuity at 4, 6. Let's see if that's true. Okay. Yep, there's a straight line. Okay. Now, if I click here and it starts scrolling, you guys can watch the coordinate. Let's get it to x is 4. It should be a discontinuity at 4, 6. It is. Aha. You guys see it also opened up a hole right there. So 4 undefined. Aha. Is that? All right. Right, so that's all the fundamental puzzles right there. At this point, yeah, you guys should be able to get everything you need on 9394. All right, so double check, make sure your name is on your notes, turn your notes in, and then I can help you guys out with whatever you need on notes.